Hi. Hi, everyone. Thank you. Yes, as mentioned, I will be talking here about REST APIs and more concretely the journey of REST APIs in the world and what it's used for. So, to introduce myself, my name is Mike Joosten. I'm a coder by trade, socializer sometimes by fun, and musician also in my spare time. I'm a trombonist as well. I started at Excelis and ING in 2019. Currently integrated at ING successfully in October of 2021. And other than that, what my main role is at ING, I'm a software engineer, mostly working for fraud case applications and compliancy tools. Funny thing, I work in a Java team, but my main coding language is .NET. Other than that, even my coding language is .NET. I'm officially Oracle certified in Java. Should it be the case that I ever need to work in Java someday? So, to give you a bit of an overview what's to come, we will talk a bit about RESTful APIs, RESTful what. We'll deep dive a bit further into the code structure, and at the end there is a demo, and of course we'll end with Q&A. What is RESTful API actually? Well, it's a combination of two acronyms. First, starting with REST, which is representational state transfer, which is a software architecture. The main focus of REST APIs is to have a division, a separation between the server, which is generally the backend, and the client, which is generally the front end. And it's a way to communicate between those two systems. Also noteworthy is that it's a stateless interaction. So it means nothing is stored, there is no persistence. It's a request done through HTTP from the server to the client and vice versa. And it's not stored, that transfer. Furthermore, API, Application Programming Interface. It's a software interface where we can connect through. So it's generally used for typical software use and these things. Also noteworthy, it also works with, like REST says, with a backend, a server, which is generally the database, and the client, the visuals, which is shown there. And it works through endpoints. Endpoints which are generally are URIs, Uniform Resources Identifiers, which we also well known as URLs, which we typically use to surf the web and get to different pages. So to understand REST APIs a bit better, we're going to focus a bit more on HTTP, the main protocol that runs it all, Hypertext Transfer Protocol. The main use for HTTP is to send in requests between the server and the client through HTTP requests, and also get responses back and knows how to act. As you can see, generally the structure of a HTTP request is using an HTTP verb, HTTP request headers, a path to a resource, and an optional message body. At HTTP responses, we get a status code, response header, and an optional message body. Getting more deeper into that and clarifying that a bit more, we're going to have a look at the HTTP request. So generally, a HTTP request uses HTTP verbs to define what action it wants to take. Generally, get, post, put, delete are the most used ones, where get retrieves the data, put updates the data, post creates the data, and a delete removes the data. There are also other verbs like patch or option, but those are mostly rarely used. We also use a URI route with parameters, query parameters like search, where we do a query search to find certain objects within our API. And last but not least, we also use accept parameters, like for instance MIME types, or currently how we call it like media types, which gives us an idea about the formatting. Why do we use MIME types, media types? It's for security measures mostly. It's to be aware which type of file is getting transported between the client and the server. For instance, an attacker could push a different type of file with malicious content in it as a text file. And if we say we only want like video files, okay, it gets neglected and the text file is not transported. Also important is that we use a certain type of file format to send the data over from the client to the server, or vice versa. It's our way of communicating. And generally in these days we see two types of data formats, file type formats, JSON and XML. The most used these days is JSON. JSON is the most familiar one and the most seen one, while you're having XML, which is typically used less and less these days. What does those file formats contain? Just words, generally words. Words containing what the item is. For instance, here in this example, it's about routers. Which type of routers, which vendor, and so on and so on. Then we have a look in the HTTP responses. The HTTP responses, it's the information that's generally given back after doing a HTTP request. And these responses generally have HTTP status codes. The status codes define what happened, and what went wrong or what went well. Generally, the 200 codes means success. It went very well, it went good. We created the object, for instance, the 201. We had an OK, we retrieved the object, a 200, or we retrieved no data back, a 204. Then we have the 400 codes, which are very important to know, because those are generally client errors. Those are generally errors that you and I make when we search something or try to do a certain action on the web. These are generally the 400 bad request, the 403 forbidden. If you have a forbidden one, it means that you're not authorized to do something. The famous one, the 404, page not found. If you don't have any internet or network connection or go to a wrong URL, you get a 404 not found. A funny one, which they put in Easter, I'm a teapot. It's the 418. So if you want to have fun and ever create a REST API, you can always slip in the 418. And then you have the 500 server errors. Those are the worst. Those are generally, like it's mentioned, server errors. Things going wrong on your IIS server or on your Tomcat server or any like those. The most famous ones are the 500 internal server error and the 502 bad gateway. So generally, if we tend to go to a page through a URL, for instance, youtube.com/TV, and we do a search, we can have a check in the network tab under the developer tools. And what we can read in these developer tools are generally information like the HTTP verb that we used, for instance, the get, the response code that we got back. In this case, it's a 200, which is an OK code. We get a lot of extra information, for instance, in the request header, going more into data like the accepted MIME types, for instance, text/HTML. The encoding used, cookies, it goes really far. And as you can see, also the URI resource, the uniform resource identifier, for instance, the search query in this case. So where is the API now located? To simply give a quick overview, the REST API is always in between the client and the server. Generally, we do REST requests or HTTP requests, how we named it here, to do a request to the server using one of those verbs, get, post, put, or delete. And from the other way, we get a response back from the server, generally a representational file format, XML or JSON. Sometimes it can be also a video format or something, then it's generally returned in a different type of file format. like for instance a base 64 string, which then gets converted to the actual video. Once again, API lies in between the realm of front-end and back-end. APIs are the connection between the front-end and the back-end. And as you might notice soon, the advantages of an API, of course, we can use it for any application if the API is useful for that application, for instance. So going further on the advantages of APIs, one of the first advantage why we should use it, it's scalable. It's easy scalable because it's relatively easy to adapt. We have a uniform interface, an interface that is globally defined in certain rules, certain ways how we build APIs and those code structures. So it's a general set of rules that we adhere to. We're also not concerned about the client application because it's loosely coupled. Those are independent components. As you remember, I said RESTful. REST generally means that the client and the server are not linked with each other. A good example are, for instance, weather APIs. Weather APIs can be used on different instances. For instance, on our smartphones, where when we open it, we see the weather. It uses a weather API. But it can also be used by, for instance, the Meteorological Institute. And they could hook up to that weather API and gain extra information from a neighboring country, for instance. Other cases like APIs, traffic APIs, for instance, GPS data that we have from Microsoft or from Google. We can hook up onto those and use it for our own applications, for instance. We can use the Google Maps API to get the information, and so on and so on. So as you see, an API might have its specific use case, but it can be used by multiple applications and multiple instances. Other thing of APIs, flexible. Like one said, it's reusable for multiple applications. It can be consumed by applications in different coding languages. That's also important, because it means an API generally these days are written in C# or Java. And in some older instances, it might also be Python, Node, or PHP, for instance. But it doesn't mean that our client application needs to be written exactly in C# or Java, or it can be either way. You could have a .NET API while the front end is made in JSP, for instance, in Java. Or you get a Java backend where the front end is, for instance, just Angular, which uses JavaScript. So we're not dependent on the programming language that the API is coded in. A disadvantage, though, of APIs, once the projects get complexer and bigger, it's harder and harder to maintain those APIs. You get an overload of endpoints, very much endpoints to connect to, very much to assemble to. And another point is also the overfetching of information, which becomes a waste of network. Because the bigger your API is, certain endpoints can be used multiple times by a lot of users, which creates a strain on the network, slows down the application, slows down your network, and then you get more and more in the realms of a DDoS attack, distributed denial of service. Interesting point with APIs, we have the Richardson model. The Richardson model states there are 4 levels of APIs. Going from the lowest level, the swarm of box, going up to HYPERMEDIA controls. Generally, the 2 at the bottom, the swarm of box and the resources, we don't try to get those APIs because those are generally the worst. The HTTP verbs, the level 2s, are the ones we use most these days. And the HYPERMEDIA controls are interesting, but takes a lot of time to develop. So, to go a bit deeper on the swarm of box. Swarm of box, plain old XML, is just a way of saying, okay, we use HTTP to communicate. which is already nice, but we only have one single URI, one single URL endpoint. So this means, for instance, we have a URL that's called api.example.com/first-post. That's our API. If we want to go to our second post, we need to enter api.example.com/second-post, and so on and so on. So for every action, there is one single endpoint. Of course, as you can understand, this makes a very huge list of URLs to connect to, and not really user-friendly to use. There are some other points to mention as well. Simple, plain old XML uses, of course, XML and no JSON. And XML these days starts to become less and less used. JSON is more and more the typical use case for APIs these days. Because it's so lightweight and performance-wise, it's so usable, JSON. It doesn't make a lot of strain on the network, and it's less heavy than XML. Some design rules in the URL naming. We use hyphens that should improve the readability. For instance, with the HTTP api.example.com/first-post, we would put a hyphen between first and post just to enhance the user readability. Underscores should never be used in URIs. Why shouldn't it be used in URIs? Well, if we put a link, for instance, in a document, we can't see that underscore anymore if it's underlined. That's the main case why we don't put underscores at URIs. Everything should also be lowercase. That's the preferred way to go. And file extensions should never be added at the end. So we can't do, for instance, like a api.example.com/firstpost.json. We'll leave the JSON out at the back, the .json or the .txt at the end, just to make it a bit more secure that the attacker doesn't know which file type is getting generated or created, and to prevent misuse. Protection by obscurity, in other words. Then we get to the level 1. The level 1 uses resources. So that means we start getting an API that uses CRUD operations: create, read, update, delete. There are also different URIs to start interacting with, because we have the different CRUD operations. These are, for example, the api.example.com/add article, api.example.com/update article, api.example.com/delete article. So the naming and the action is still in the URL itself. And some typical design rules: we don't use trailing forward slashes. If we use those trailing forward slashes, that's just an extra slash that is no extra use given to the URI at all. And it would imply that if we use a trailing forward slash, that there is something else to come. Forward slash separators must be used to indicate hierarchical structure. So we use slashes between the controllers, which we also dive deeper into, to have the hierarchical structure of our APIs. And there is also a consistent URI formatting. So only using singular names, like for instance, update article, then the other things need to be also singular, like update post, for instance. Or if you use plural names, update articles, then update posts also needs to always be plural. The level 2 are the most interesting one. Almost like 99% of the APIs running in the world are level 2 APIs. They generally use CRUD operations, but the thing is, they use CRUD operations on through HTTP verbs. The nice thing about that is that we have a smaller list of URIs to use. We can do, for instance, api.example.com/articles, and when we send that URL request, we add an HTTP verb added, like a get HTTP verb or a post or a put. So we have one URI that can do multiple actions. Also added in this category are the query parameters. We can do, for instance, paging, dividing a list of resources in smaller pages. We can do filtering, restricting the number of queried resources to a certain set of attributes. We can do sorting, for instance, sorting the list of data we get, ascending or descending. And we can do, of course, also searching, like Google that works on a search-based query parameter system. We can find certain keywords within our database that we need. And finally, there are also status codes used for the request's success or failure. It gives us extra information. Also, as developers, it's easier to find out what we did wrong or where it goes wrong. Then we have the final level of maturity, the hypermedia controls. It's an extra layer on top. So we have content negotiation, where we start using the accept in the request header or the content type in the request header, adding, for instance, MIME types that we use, or also doing checks to deserialize the data. The most important part of the hypermedia controls are the HOAS, the hypertext as transfer engine of application state. Those are generally extra links within our REST API that ease the navigation through resources and the available actions. Those are extra URIs that we get to see in our API, but it's mostly used by the client application. So the list of URIs are not generally used by the client himself or herself, but generally by the client application, the code that is using those extra links. And finally, I added it, versioning. It's not entirely within the realm of hypermedia controls. It's generally situated in between level 2 and level 3. But with versioning, we add an extra layer of version control on it. We can do backward compatibility. So generally within the API's URI, you will find a V1 signature or something like that that indicates that the API is a version 1 or a V2, which indicates it's a version 2. And other than that, also added to that is documentation that can be used, like Swagger. So going a bit more into the code structure of an API, what makes an API? And we will demo it also shortly to give you a better concept and an idea what an API is built of. Generally, the code structure are the models or the beans that we use, models for .NET, C#, beans for Java, for instance. Those are generally the products, the objects that we define within our API. Also interesting are the data transfer objects, because the data transfer objects, those are a way to only limit the data that we send through our API from the server to the client and vice versa. If we use the models or the beans itself, sometimes the fields that gets transported through are way too large, and some fields we don't even need to use to send to the client to represent something visually. So we use DTOs for that, data transfer objects, which only contains the fields that we want to send through the API. The main motor under the hood are the controllers. That's generally what we see when we use APIs. Those are our typical requests that we do: the get, the post, the put, the delete. And here is also where we create, for instance, the URI endpoints, and where we also define that we get a verb action to take and the responses that we get back. And finally, we have sometimes mappers and validators. Those are more used to translate the database entities, the models, to their respective DTO and vice versa. And the validators are used to apply rules. Like, for instance, if we add a certain object into the database, is it a duplicate, yes or no? If it's a duplicate, well, we don't go further on it. So, to deep dive into the demo and give you a view what an API is, how it works, what it does, we're going to show it in a .NET Core application. And it's constructed in a certain model that uses clean architecture. Clean architecture, also sometimes referred as the onion model, it connects differently the architecture than, for instance, our typical three-layer type of architecture, where we have a different type of connection. Starting to see in this clean architecture way of working, we have in the center our entities, our models, our beans. Those are our core data. Generally, we call it the core layer within the application. Those are the data that we mostly interact with and use. And as further as we go, the use cases is not in this case in this demo, but the controllers are. The controllers are our API, the gateways that we connect through. For instance, for mailing, we use certain gateways. But the controllers maintain the APIs. And on the outer layer, we have all our other extra values, like the user interface, the web interface, external interfaces we connect to, the database connections, for instance, in this case, entity framework. Why do we have that separation in such an onion model? The advantage of the onion model is that the dependency rules, the dependencies are not intertwined, but have a straight path to follow. That brings us to the demo. We're going to show you how an API works and what it does. So, as you can see, we have here our Visual Studio Code. And to give a bit more of a view, this is our core layer, the recollectible core. And if we see in that recollectible core layer, we have our entities. And to give you a bit more, context, what this API actually is, because as you can see, it says collectibles, it says collections, it says locations, etc. It's actually an API created for managing, for instance, someone's collection in coins, in banknotes, in objects that they want to collect. This is a minimal viable product, so it's now currently only coins and banknotes. But it can go broader. That's the flexibility of an API. We could add even different types of collectible objects, like art or like cars, for instance. So that's the main use of this API. And as you can see, there are models defined, like a banknote, like coins, like collectibles, the collector values, etc. There are also locations defined, like our countries. And once we dive deeper into that, you will see more about it. I won't deep dive too much into services, because what services are used for is to make the connection between the database and the API to retrieve the data. And our APIs makes use of those services to retrieve the data from the database. But the most important part is to have a look in our API project. And if we open, for instance, the coins controller, this is, for instance, an element from our API, which uses a path/coins to retrieve data. What this API does, for instance, we have, for instance, a getCoins getCoins retrieves all the data. For instance, as you can see, because this is a level 3 API, we can also use an 8 OAS call. It also notifies that it uses an HTTP get coins verb action. It also produces these types of response types. To give a bit more detail about what these attributes are, these are used for the documentation, for the Swagger. Once I start the application, the API, you will see it more better explained. As you can see, the biggest method is generally the get method, because we have those request parameters to look at, the filtering, the sorting, those types of actions. The page count, for instance. And also what you also can see is the mapping from our coins object to the DTO, the data transfer object. Let's have a look at the DTO, for instance. It gives us certain values. And let's open in the meantime as well our normal one. So, a coin DTO gives us a lot of extra values. In this case, the coin itself, it uses, it expands from a currency, which expands from a collectible. So the list might be larger than what is given here. What we define in the coin DTO, for instance, are only the core necessary details that we need to visually represent on our client application, limiting the data that is actually upheld in the background. Further than that, what we also see, if the actions were a success, we get an OK response, which is generally a 200 status response. And furthermore, should it go bad, in between, you see the return bad request, which is generally a 400 response done. And as you can see, we have the different actions. We have a get coin, which gets us a single coin object. We have, for instance, the create coin, which is our post, which creates a coin. We have our, for instance, the update coin, the put, which puts a coin in. We also have a special one. It's the partially update coin, which is our patch. The advantage between a put and a patch, a put updates the entire object, the entire coin object, while a patch only updates certain aspects of that coin object, only certain fields or certain details. It doesn't replace everything at once. And we also have, of course, our delete, which actually removes the coin. So, if we are going to start the application, needs to run and set up a local host connection, which might take a bit of time, of course, knowing Microsoft. But there it comes. This is actually a Swagger interface. So this is our documentation showing us what the API actually does and what we can do with the API. And if we, for instance, go to our coins interface, we can try it out. We can run and execute in Swagger. And what it will show us is the request URL it made, which is like /coins. It returns us our JSON information, which is data about the coins that are in there. And for instance, if we look at the JSON information, there is, for instance, a silver coin in there referring the 200th anniversary of Ecuador, for instance, one sucre. We can even, in those gets, we can do a certain filtering. We can, because for instance here, to show you, there are 3 coins actually returned, 1, 2, and 3. So if we do filtering, for instance, and we say we want page 2, and we want the page size of only 1 coin, for instance, we can try it out, do an execute. Perform an execute, and it will return us only 1 single coin. The second one, Mexico. As you can see in the URL request, there are query parameters now in there. It says page 2, and the page sizes are only 1. So there are 3 pages with each 1 coin in it. Let's go have a look a bit more down. We're going to go to a smaller object, which is the countries. If we would do a get of the countries, we get 4 countries in here. Canada, Ecuador, Mexico, and the United States. Let's add an extra country, won't we? So to create an extra country, we'll do a post request. When we do a post request, for instance, we'll add in our JSON, the JSON content that we will send to the API. We'll add a name, Netherlands. We'll add a description, most awesome country in the world. I think a lot of Belgians will hate me for this, but at least let's execute it. And as we see, we get a 201 status code, which says it was a success. This is now added to the database, Netherlands, the most awesome country in the world. And we can actually retrieve, get the countries, for instance, and you will see it's actually in the database now. So if we now execute it, we have 5 countries, including the Netherlands, the most awesome country in the world. Going further on that, we can also do a BAT request. So we could also try out at a new country. Just name 1 country. Belgium will go for the BAT request. Super. Representing my country here. All right. We'll do a BAT request, which is adding Belgium. Failure in the in the process. When we do an execute, it gives us a 400 code, an error code. Why did it give us, in this case, an error code? Because I didn't add the extra quotation marks, which is a fault done by me, the client. So that's why we get a 400 error, well, BAT request error, which generally is the fault of the client, me in this case, or sometimes the client application, because sometimes it can be also something wrongly done in the code by a developer and it isn't entirely the fault of the user. All right, super. If we execute it again, let's add it to the database. All right. We have a put. With a put, we can update, for instance, a country. For that, we need an ID. And to find that ID in this case, because it aren't those typical IDs, those are GUIDs that it uses. We can actually, for instance, update Canada, where we use Canada's ID. And as you can see, if I remove the tree, for instance, and I try to do the request, it will give me a error, at least already in Swagger itself. Okay. Let's change Canada to a different country. Luxembourg. We're going from a big country to a tiny Luxembourg. Okay, great. We'll create Luxembourg. Down south. All right, if we do the execute, we can see it was a success. And Canada shouldn't be anymore in the list. Canada should now be Luxembourg. So if we have a look, well, yes, we have Belgium, Ecuador, Luxembourg, Mexico, Netherlands, and the United States of America. All right. Going further, we also have a more specific action, like a patch request. And in this patch request, we also need the ID of the country, for instance. Let's grab the United States, for instance. All right. The United States are added. And let's do a replace action. So if we would be doing an operation replace like this, to what will we replace the US to? Shout out the country. Germany. Ah, it already was Germany. All right. If we would execute it, it gave a bad request. Because it has too many accolades. So if we execute it now, it should give us a success, and the US has become Germany. All right, and of course, if we would do a delete, for instance, Ecuador, which is a tiny country, we can perform a delete right here, try it out, and we can delete Ecuador. Execute, and Ecuador is successfully deleted. Okay. Okay, now we will show one final thing, which is the H80AS links. So, if I would, for instance, change my accept header to a application JSON 80AS, and I would execute it now, what we will see is we'll get a bunch of extra information afterwards. We get the country, Belgium, for instance, our failure in the process, and also the links added to it, which we can do different requests again with it. We can do a get, we can do a post, we can do a put request, we can do a patch request, and we can do even a delete request. And as you can see, there are also the links added to those. For instance, if I want to get only Belgium, I need to go to this URL, and it will only get me Belgium back. If I would use that URL with a delete verb method, it would delete that case out of the database. So that's in plain essence how an API works and what an API does. So going further on this case, we get to the point of questions, and feel free to ask. Thank you.